Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today we're going to process the Western Veil Nebula in the SHO color palette in Pixinsight and Photoshop. So this is probably going to be a little bit of a long video because I want to go through both the Pixinsight workflow and Photoshop. Probably like most of you, my workflow continues to evolve and change, so there's probably some things I'm doing differently now than the last time I did one of these full walkthroughs. I'll do it in two separate videos, one focused on just the Pixinsight process, and then a second one focusing just on Photoshop. So if you're interested in just the Photoshop, you can jump to that video. If you're interested in just the Pixinsight, you can watch just this first video. So with that, let's jump into Pixinsight. And if you've watched my videos before, you know that I use Pixinsight primarily as a front end to Photoshop. So my goal here is not to get a finished image. My goal here is to get some files in 16-bit TIFF format that I can load into Photoshop for further processing. So to start with, I have already run these files through WBPP, but let's look at what that setup was like. Now the first thing I did, I imaged these last night with the plane wave 12.5 inch, and the first thing I did this morning was go through the blink process and pull out any of the bad subs where the wind caught it, or for whatever reason they just weren't as good as the rest. I usually try to leave enough, so Pixinsight needs at least 3 subs in order to do an integration. So I sometimes will fudge a little bit and leave one in that, even though it's not good, that gives me the full 3. I'll probably image this again tonight and then add to it that data tomorrow. So let's look at WBPP first. So we'll pull up the under scripts, batch processing, weighted batch preprocessor. And this is really a great tool. I've only been using Pixinsight for about a year. My understanding before this tool was available, it was a fairly onerous task to go through and do all this step by step. WBPP automates things very nicely. So the first thing I did was load the lights, and you can see here we have the hydrogen, oxygen, sulfur. Those are at 600 second exposures, and then red, green, and blue at 2-minute or 120 second exposures, and just barely kept 3 of the blue. So this is the data we're going to integrate, and then I've also loaded flats, darks, and biases, although I don't believe it actually uses the biases. And if I look at post-calibration, we can see this is about 3.5 hours of total data, so not very much time on the target, but this time of the year during the summer, you don't get a lot of time. In the calibration tab, I did a couple things. I went down to the filters, the different elements, and selected a pedestal value of 600. That's a little bit on the high side, but there's not a lot of data here, and that helps avoid some of the background issues. And then I just clicked apply to all light frames so that they all have the same pedestal value. Since this is the first time through the data, I've selected auto for the registration mode, and then I've selected an output directory of Western Veil in my Pixinsight swap files folder on my D drive. And once that's all configured, then I just hit run, and Pixinsight goes through the process and creates my set of master files. Now, like I said, I've already done this, so we'll exit out of WBPP and we'll go look at the results. And if I just double click here in the field, the background, that will bring me the file open dialog. And I want to start with the red, green, and blue. So I'll just select all 3, red, green, and blue, click open, and it's going to open all 3 of those files. And for the time being, I'm going to move this process monitor out of the way. So here are the three red, green, and blue files, and the first thing I want to do is turn these into an RGB image. So I need to combine these into the three channels. And so I'm going to start working from the saved process icons that I have over here on the right hand side. And the way these are created is, for instance, if I open up the channel combination tool, if I just click the triangle and drag out, that will create a process icon. I can then use this top to rename that and then just drag it over here and save it. And at some point when I don't have any files open, I will save a blank project or an empty project, and that saves all of these process icons for me that I have created and saved. And the reason I like to do that is it's just a lot easier to get to them this way. And we can get rid of this. So delete. I'll just delete that. Okay, so I'll pull it from over here just by double clicking on the saved process icon, and I'll just grab the red file name and drop it into the red channel. Now you can also select it this way and select green for green, and then we'll put blue into the blue channel and just quickly double check I've got red, green, and blue in the red, green, and blue channels. Click the solid circle to apply that, and that created this new file for me. And at this point I can close the process, and then I can actually close the red, greens, and blue because I don't need these anymore. We now have a combined RGB version. Let's take a quick look at it with the auto stretch, and it will probably have a strong color cast. Yep, it's got quite a cyan color cast. Typically the first thing I'll do is run a dynamic background extraction, or DBE, in subtract mode. And again, I have a saved process icon, and this one in fact is saved with samples already arrayed around the perimeter, so it's ready to go. It already has subtraction selected as the process, so I just double click on the process icon, click the check mark, and it will apply DBE to this image. And yes, I do want to close it. Let's update our screen stretch, and we'll now start to see a pretty reasonable version of the image. And this is just 2 minutes of each of red, green, and blue, 3 to 5 exposures, so not much time on this at all. But all I'm after here is the stars. Next, I will run the Spectra photometric color calibration. And again, I have a saved process icon for my mono camera with red, green, and blue filters. Since that's already configured and saved, I can just drag it onto the image. And it's now running the Spectra photometric color calibration. And that will give us reasonably accurate star colors. Since I'm only after stars from this data, I do want the colors to be somewhat accurate. Generally, I find that because we'll be putting this over a fairly colorful SHO image, we'll need to push the saturation higher than you would think. So there it is as a color balanced, and if we look at the results, we can see it did a pretty decent job. The sample points are all along the line. Next, I'm going to run Blur Exterminator. And something I've started doing a little different from what most people do, and I occasionally get some pushback on this because people say, oh no, you're not supposed to run DBE twice. Well, I run it once on each of 2 copies. So the first thing I want to do now is duplicate this image. And so we'll just choose duplicate, and now I have image 4 and image 4 clone. And I will start by running Blur Exterminator with aggressive settings. And when I say aggressive settings, let's open this up. I have moved the sharpen stars up to 0.32. So it's a pretty aggressive setting for sharpening. We'll go ahead and apply that. And what this is going to do is, my main focus here is sharpening and reducing the stars. Since all we're getting is the stars from this RGB image, I don't really care what it does to the background. I really want it to just sharpen the stars nicely. And it usually does a very good job. Each one of these AI steps generally runs about 30 seconds. So for the most part, I'll just kind of ramble on a little bit while we're waiting for it. And it's about done. I'm watching the process monitor. We're at 95%. And there it is. So that has sharpened up the stars significantly. Now the second version I want to run, I'll run on this copy of it. And for this one, I have what I call fluffy stars. I'm sharpening the stars a little bit, but mostly I'm pushing this adjust star halos, I'm pushing that up to 0.3. And what this is going to do is kind of highlight and expand that halo that shows up around the stars. And the halo is really where most of the color winds up. So this image is going to give us that little bit of soft glow around the stars. It's also going to give us a lot of the color. And when we get into Photoshop, we'll choose how we want to blend these two using the sharp stars as kind of the foundation for the star layer. And then we'll add some of the fluffiness and the color just by eye to bring it to what we think is the perfect balance. So this is completed now, and if we compare the two, you can see that there's quite a difference between the sharp version over here and the fluffy version here. Now I'm ready to stretch, so I will pull up screen transfer function, and I need to rearrange my screen real estate a little bit here, and the histogram transformation tool in order to apply it. And we'll just update the screen transfer function, and I'm using the scroll wheel on the mouse to zoom in and out so I can see the sliders here. The left one is the black slider. If I move it to the right, it will darken the background, which is great. That's kind of what I'm after. And then the right slider is actually the midtones, and we just find a spot where we think the stars look pretty good, and then I will just grab the triangle, drag it down to the bottom bar of the histogram transformation tool, click the square to apply that, and we have now stretched this image. So I'll turn off the screen stretch, and that's the final image. You can tell it's not stretched because the green bar on a screen stretched image shows up over here. On this one, the fluffy one hasn't been stretched yet. And I'm just going to apply the same parameters to it. So I'll just grab the triangle, drag it over onto this image. So we've actually applied the same stretch to both the sharp and the fluffy stars. Close these to get them out of the way. The last thing I'll do is run Noise and Star Exterminator, and I'm saving the stars. Now, what I have over here, let me talk a little bit about this. This is a process container. If you're not familiar with the concept of containers, in Pixinsight you can have an image container, which is a set of images that you can then act on, and it will, if you run a process on an image container, it will run that process on each one of the images. You can also have a process container. The first was an image container. A process container actually contains multiple processes that you could run on an image container or a single image, which is what we're doing here. So in this case, I've configured Noise Exterminator and Star Exterminator with the settings I want, and then I can just drag this process container onto the image, and it runs both noise reduction and Star Exterminator and saves the stars all kind of in one fell swoop. And that leaves me free to chatter about it. And there's our sharp stars. There's some reasonable color there. So at this point I will save this, and I'm going to save this as I'm saving this just as a 16-bit TIFF, And I'm saving this in the kind of the folder, the master folder where my light frames are stored. So if we're interested, there's the RGB background image. We're not really going to use that for anything, but I'll now run Noise Exterminator and Star Exterminator on my fluffy star image. And again, all we're after is the stars, and then in Photoshop we're going to choose how we want to blend the fluffy halo that has the color with the sharp core of the star. I can't really give you a good rule of thumb for what's the right amount. It will vary depending on the background nebula that you're putting it over top of. The one thing I have found is you almost always need more saturation than you think, because you're putting it over a colorful image, and the saturation in the stars just kind of gets lost in the shuffle if you don't, really push that saturation up somewhat. At this point, the files are still pretty malleable, more so than they will be as 16-bit TIFFs. So I try to do as much of that processing as I can while I'm in this state in Pixinsight. And one of the things I'm going to do is increase the saturation of these fluffy stars. And I do that with curves. And again, I have saved a curve setting that just has some plus saturation, so I can just drag that over mindlessly, apply that, and that increased the saturation. And I think the last thing I'm going to do is run some green reduction. So I'm going to go to Process, All Processes, SCNR, green is selected, and I'll take this down to maybe 70–80%, and we'll run that just to knock some of the green out of this image. And now we'll save this. And again, I'm in my Western Veil folder. This is Fluffy Stars 2. And again, we'll save this, specify 16-bit for the TIFF file. So this is done. Now we need to go through the SHL files. And I'm just going to close this. I'll double-click in the background again. Now we're going to open sulfur, oxygen, and hydrogen. And it seems like I always work these in the same sequence. For most images, hydrogen is the one that's going to be most dominant. And I kind of like the idea of saving hydrogen for last, because it has that ooh, aha moment when you first stretch it. So we'll save that for last. We'll start with sulfur, which is usually the weakest of the signals. I'll throw a quick screen stretch on it and see what we've got. And there's a surprising amount of sulfur signal here. I'm not going to run DBE on these. I find if I do run DBE, unless I really have a visible gradient on the monochrome images, it seems to do more harm than good. So I'm going to jump straight to Blur Exterminator, and since we're removing the stars from this, I don't really need my sharp stars or my fluffy stars, so I'm just going to run plain old Blur Exterminator, and that will focus primarily on the background nebulosity as far as applying Blur Exterminator to that. Once this is done, we'll do a quick stretch, remove the noise and the stars, and then this will be ready to save as a 16-bit TIFF. I don't get too worked up over the stretch that I do. I know I've played around a little bit with the generalized hyperbolic stretch, and let's just go ahead and do this, and then we'll talk about it. So I'll update the screen stretch, zoom in just a little. I'm going to darken the background a little and bring up the highlights a little, but I want to make sure I don't have anything going to black and anything going to white. I want just nice smooth tones. Bring this down to the histogram, apply that, and then now we'll run Noise Exterminator and Star Exterminator. This is a second process icon for those two that does not save the stars, because all we want from this is the data. I was talking a little bit about the stretch. GHS, the Generalized Hyperbolic Stretch, is a real nice tool. It's a parametric curve. In other words, you're using parameters to determine the shape of the curve, but there's nothing really special about that curve. It's just a curve. It happens to have been calculated a certain way using the parameters that you feed into it, but it's still just a curve, and you could draw that same curve in the curves transformation tool or with curves in Photoshop. So, and I do find that easier. I would rather work with the curve directly than work with parameters to try to get the curve that I want. So here is our sulfur stretched, noise reduced, and stars removed. And you can see there's some obvious star residual here and there that we'll clean up in Photoshop. So I will save this now as a 16-bit TIFF. And now I have to navigate to the correct folder where I'm storing my Western Veil data, change this to TIFF as the file format, and again I'll give this a number 2 suffix, specify 16-bit, okay, and now it's just somewhat of a rote process. There's our oxygen, again good looking data. We'll apply Blur Exterminator. This too is probably going to wind up with some star residuals that we'll need to clean up in Photoshop. For me, I find once I get to the point that I've got a nice monochrome image, they almost always need some finessing, some cleanup, removing star artifacts. I need to map the colors, possibly reduce noise, possibly do some sharpening. All that is very easy to do in Photoshop, and I say that because I'm familiar with Photoshop too. I've been using Photoshop for decades maybe. I started digital imaging in the mid-1990s. So I'm just doing the adjusting the screen transfer function on the oxygen layer. And I don't want to get the background too dark because there is a lot of fun stuff going on back there. So we'll apply that. And again, my main goal here is to have a good range of tones that uses the full histogram. Apply noise and star reduction. Yeah, I started digital imaging in the mid-1990s. At that time it was kind of a hybrid workflow. I would go out and shoot with color negatives. Take those to Walgreens or Walmart or somewhere with 1 hour processing and just get the negatives, no prints. And then I would look through the negatives and scan the negative that I wanted to work with into the computer, and then I could use Photoshop, or I was actually using different tools in the mid-90s, and process those. Processing was pretty crude in the 90s. Printing was even cruder. Color management was almost non-existent, so it was really kind of a challenge. So now we'll save this. And again, we have to navigate to the correct folder. Specify that we want to save this as a TIFF file. Add the 2 suffix, 16-bit TIFF. And I'll just drag this down here to save it for now. And now we're ready for the hydrogen. This will be the kind of the last file to run through here. Again, we will start with Blur Exterminator. Color management is really the process of getting what you see on your monitor to match what comes out of the printer. And as printing tools have evolved over the last 10 or 20 years, the printing process is pretty well cut and dried and defined. If you use the right setup for your printer, in other words, you've got the right settings for the paper and ink that you're using, which is pretty easy to do, and you have the software configured correctly to use the correct color settings, then for the most part, you're always going to get the same result out of the printer. It's not much of an art anymore, it's just a process. But you need to get your monitor adjusted, and monitors are not nearly as well defined as printers. You need to get your monitor to match what's going to come out of your printer, and what's coming out of your printer is pretty standard. So the good news there is that what you want to be on your monitor is also pretty well defined as a standard. And so there are tools you can use to calibrate your monitor so that your monitor shows you correct standard colors. And then if you're looking at correct colors on your monitor and you're getting correct colors out of your printer, then you have a pretty predictable process, and what you see on the monitor is pretty close to what's going to come off the printer. And the benefit of that is it saves you a lot of time and a lot of money on paper and ink and trial and error trying to find the right color. Generally, you almost always want to adjust your monitor to match printed output, not the other way around. If you get into trying to adjust your colors so that they come out right on the printer but they don't look right on the monitor, that's just kind of a lose-lose situation. So there's our hydrogen starless. We'll save this, and again we'll have to navigate back to our Western Veil, specify this as a TIFF, add a 2 suffix to this, and save this as 16-bit. Now the last thing I sometimes do in Pixinsight is, just for fun, throw these together into an SHO to see what just a true, kind of stock, unadulterated SHO image looks like. So to do that, again, I'll go back to my channel combination. I'll grab my hydrogen and drop it into the green, because that's what SHO is. Sulfur in the red, oxygen in the blue. Just double check, we have sulfur, hydrogen, oxygen, SHO in the red, green, and blue channels. Click the circle, and that's what I'll call it a pure SHO image looks like. Somewhat garish, not particularly attractive. I think we can do a lot better. So what we're going to do at this point is I'm going to end this video and we'll pick it up again in Photoshop. We're going to take these 3 monochrome images, the sulfur, hydrogen, and oxygen, plus the 2 versions of the stars, the sharp and the fluffy, and we're going to load all these as layers in Photoshop and then finish the processing there. So I hope you found this useful. You may still be watching, you may have already jumped ahead to Photoshop, in which case you're not hearing me. But if you are still hearing me, I hope you have a great day today and an even better night tonight under a clear, dark sky, and I will see you in part 2.